Hi everyone, I'm Alison. In this video series, I'll be going through A-level biology content and break it down into short and simple concepts. But before we can dive into the larger biological concepts, we first need to understand the smaller scale biology. And in today's video, the even smaller scale chemical principles behind it. So today we'll start off with the atom, quite literally the smallest element of the smallest particle of an element. We'll be looking at the atomic structure, and what atomic number, isotopes, and atomic weight means. This video is meant to be just a refresher for the ones of you that have covered all this before in your GCSEs, and just to give you a bit of an overview if you've never come across this before, so that future videos will make more sense and you'll have more background information on why certain things happen the way they do. So, elements are made up of a single type of atom, and atoms are made up of three subatomic particles: protons, neutrons, and electrons. An atom, which is what I've drawn here, has a central part, which we call nucleus, that contains protons and neutrons. Protons have a charge of +1. And because atoms are so incredibly small, scientists have come up with a specific unit to describe their mass. And that is called the atomic mass unit. Protons have an atomic mass unit of 1. And neutrons, on the other hand, do not have a charge, but also have an atomic mass unit of 1. Electrons are found outside the nucleus, just orbiting around it, have an electron charge of -1, and because they're even smaller than protons, they're much, much smaller than protons and neutrons, their weight, their mass, is roughly 2,000 times smaller than the one of protons or neutrons. Therefore, it's basically negligible. And that's why when we talk about the mass number of an atom, we only look at the number of protons and neutrons found within that atom. Another interesting thing to notice is that for atoms, the number of protons always equals the number of electrons. Therefore, the charge of protons will always cancel out the charge of electrons. Protons are also interesting for another factor, which is that they are what differentiates one atom from another atom. So over here, I mentioned that elements are made up of a single type of atom, and the different types of atom are given by the number of protons found within that atom. We call that the atomic number, which is quite simply the number of protons within that atom. And atomic numbers is how elements are organized in the periodic table. They're also organized by other different information, like their the type of element that they are. If we look at the atomic number for the atom that I've drawn, we can see that I've actually drawn a lithium atom because lithium has 3 protons. You might have noticed that the atomic weight for lithium is 6.94. Now, this might surprise you a little because I've mentioned that the mass number of atoms is the protons plus the neutrons. And in this case, there are 3 protons and 3 neutrons, so the mass number would be 6. So it's a little bit odd that on the periodic table it says that the atomic weight is 6.94. But that's because the atomic weight is not the mass number, and the atomic weight has to take into consideration isotopes. So, isotopes are atoms that have the same number of protons but different number of neutrons. Because they have the same number of protons, they are the same element. but because they have a different number of neutrons, their mass number changes. The way I like to remember isotopes is to imagine that elements are little families, and isotopes within that family are brothers. So because they're all brothers from the same family, they have the same surname or proton number. But because they're different individuals, they're brothers, they have different names or neutrons. So what the periodic table has done to accommodate for the many different types of isotopes that are present for a single element is using an average of the mass of all the atoms of an element, but based on their abundance of the isotope. So if this isotope is more abundant than this isotope, the atomic weight is going to be closer to this mass number. I hope that this has been useful in just recapping some of the information that you might have known already, or if you're brand new and just come across this for the first time, I hope it was simple enough for you to be able to follow along. In the next video, we'll be looking at the different type of elements that are most commonly found in biology and what types of bonds they form. This is going to be very useful for other information down the line. Thank you for watching, and I'll see you next time.